Examples of pressure controlling valves use limitation of the pressure in the system, pressure reduction, control of input oil pressure, and loading of the pump. The simplest example of a pressure controlling valve is the spring-loaded ball or poppet valve, which we see here. Sometimes it is provided with adjustable spring tension. Among the pressure controlling valves one can discern the following groups: pressure limiting valves and pressure reducing valves. The function of the pressure limiting valves is to prevent the oil pressure in a system from exceeding a set value. By the spring being compressed when the valve opens, the pressure at full fluid flow-through will always be higher than the opening pressure. Since the opening pressure is lower than the flow-through pressure, the valve must always be set to a lower pressure than that which is the highest permissible for the system. A pressure-limiting valve must always be in the pressure line from the pump. The valve is most often placed as the first component after the pump. Thus it protects all functions that are supplied by the pump. This type of valve can also be found in other places in the system, but then with another name and a slightly different purpose. More about that later. In systems with high pressure and high flow, it is preferable to use pilot-controlled pressure-limiting valves. Play the animation. A small spring-loaded pressure-limiting valve is built in as pilot valve in the main valve. A channel ensures that there is the same pressure on both sides of the large valve peg. When the pressure increases, the pressure also increases against the pilot valve's peg. When the pressure on the pilot valve is increased to opening pressure, the oil pressure drops on the main valve's rear area, and it also opens after a moment. Since the opening pressure in principle is the same as the flow-through pressure, the valve can be set to the highest permissible for the system. In the picture, you see a simplified hydraulic system consisting of hydraulic tank, pump, directional valve and a cylinder. You see that the system is of the type open center. To get the cylinder's piston rod to move up, we must change the directional valve's position and connect the cylinder's plus side to the pump and the minus side to tank. Even when the cylinder has reached end position, the pump will continue to deliver a flow to the cylinder. This makes the pressure increase in the system, and its weakest link ruptures when the pressure becomes too high. Play the animation. To prevent this from happening again, we now see that we need to install a pressure-limiting valve. We place it as close as possible to the pump to protect the system. Start the animation. When the pressure increases to over the set value for the pressure limiting valve, the valve will open the connection to tank. The flow can then take another way than to the cylinder when the piston rod has reached its end position. If the valve is set correctly for the system, it will manage the pressure level that one reaches, even with the piston rod in end position. Now, if a strong force should load the piston rod when the directional valve stands in neutral position, what will happen if we try to lift the load by changing the position of the directional valve and connect the pump with the cylinder's plus side? The higher pressure on the right side of the directional valve and the internal leakage in the pump results in the oil beginning to flow towards the pump instead of in the opposite direction. This results in the piston rod being pressed down until the pressure in the system exceeds the pressure caused by the force on the piston rod. Start the animation. This can be prevented with a non-return valve correctly placed before the directional valve. This is called load-holding valve, as it holds the load until the pressure from the pump side exceeds the pressure on the cylinder side. Here we see the same system as before. What happens if a strong external force from above should load the piston rod when the directional valve stands in neutral position? Play the animation. The pressure on the cylinder's plus side will increase quickly, as the oil is trapped between piston and directional valve. If the pressure becomes too high, the hose will also rupture in this case. Here one speaks of shock pressure. To prevent this from happening, one must install another pressure-limiting valve in the system. We call the valve a shock valve and install it between the cylinder and the directional valve. That which happens is that the pressure is limited by the shock valve that opens a connection to tank for the surplus oil when the pressure exceeds the valve setting. Start the animation. What happens then on the cylinder's minor side at corresponding shock? When the piston rod moves downward and the volume on the minor side increases, the pressure will drop on that side as the oil volume there is trapped. Then, as mentioned earlier, the phenomena cavitation and dieseling effect can occur. Play the animation. Cavitation or dieseling effect can be prevented by installing a non-return valve between the cylinder's minor side and the tank. We call it an anti-cavitation valve because when it opens, oil is pressed into the cylinder's minor side if a vacuum is created there. Pressure-reducing valves limit the pressure in a certain part of the system to a lower level than the maximum pressure in the system. As a rule, they also maintain maximum pressure in the subsystem at a constant value, regardless of pressure changes in the main circuit. When the fluid pressure in the branching line has reached set value, the oil pressure in the channel lifts the valve slide, and the slide closes between inlet and outlet. The spring housing is connected to tank to prevent hydraulic lock. The shuttle valve has connections to several inlets but only to one outlet. The incoming oil with the highest pressure is connected to the outlet, and the inlet with the lowest pressure is closed by a sealing steel ball. A shuttle valve is used where several different signals can activate one and the same function, or if prioritizing of different pressures is necessary. A servo valve is in principle a number of variable pressure reducing valves. This means that the valve can reduce the incoming servo pressure to a lower output control pressure. With this pressure, directional valves can be controlled variably so that the movement speed of users can be varied. Start the animation. Single acting cylinder. On the left we see a single acting cylinder, and its piston is returned to its start position by an external load or a spring. The oil can be supplied to the cylinder on the piston rod side or on the opposite